So as we continue on with these examples that relate to our integer exponents and our other rules for exponents, I want to look at part D of this example that we were working on, and that is we want to simplify this. Now again, there is not just one way to go about simplifying these negative exponents. You could distribute, apply the multiplication rule of the exponents first, and in many cases that's going to be easier because it'll produce some, if not all, positive exponents. Or you could choose to just flip the base entirely to make the outside exponent negative. In this example, I decided to multiply the exponents because I saw right away that if I multiply the numerator exponent of -3 by the outside exponent of -1, I get a +3 exponent. And the same thing happened in the denominator. If I multiply the denominator's exponent of -2 by the outside exponent of -1, I get a positive exponent there as well. That's nice. So now I have 2 times 2 times 2 on top, which is 8, and 3 times 3 on bottom, which is 9. So my final answer just turns out to be 8/9. Looking at E, this is one where I notice both the power in the numerator and the power in the denominator have negative exponents. I want to get rid of them. So this is what I was emphasizing in class, that if you want to change, if you have a fraction and parts of that fraction have negative exponents, just move those parts of that fraction to the other location. If they're on top, they move down. If they're on bottom, they move up. So that 10 to the -2 can move down to the bottom, and it becomes 10 to the +2. And that 10 to the -4 can move up to the top, and that becomes 10 to the +4. So I get 10 to the 4 over 10 to the 2, and that becomes 10 to the 2. The other way you can do it is just apply your subtraction rule, but I know we're much more likely to make mistakes when we add and subtract negative numbers. But you can take the numerator exponent of -2 and subtract -4, the denominator exponent, and that also produces a positive exponent. So regardless of which way you do it, you're going to get the same answer, 10 squared, which is the same as 10 times 10, which of course is equal to 100. Well, of course, we're going to make it interesting. We're going to throw in some variables. These are what we call expressions algebraic expressions instead of numeric expressions. The rules don't change. We still know to add these exponents. And we get x to the 2 plus -5, which is x to the -3. You are never finished simplifying if you still have negative exponents. So the way we get that x to have a +3 exponent is to flip it. It'll become 1 over x to the +3 power. Here, I like to get rid of my parentheses and all other operations if possible first. So -2 times 4 is -8. I don't like negative exponents in my answer. I'm not done simplifying. So I can make that x to the -8 power become a +8 power by moving it from the top to the bottom, or think of it as taking reciprocal. That'll become 1 over x to the +8 power. Here, we're just adding more variables. We still apply the rules in the same way. We know to multiply our exponents on this one. So the exponents on the x, 2 times -4, and the exponent on the y will be -3 times -4. Well, 2 times -4 is -8, but -3 times -4 is +12. We're not done because there's a negative exponent in there. It's on top. We can move that x down to the bottom, only the x, because it's the only thing that has a negative exponent. And when we do so, it's going to become x to the +8 on bottom. The y to the 12th just stays up where it is, and they can be written in the very same fraction, y to the 12th over x to the 8th. In this one, we could do it in one of two ways. We could go ahead and distribute, multiply those exponents. for both the numerator and for the denominator. Or you could choose just to flip that entire quantity in the parentheses. All of the exponents inside will stay the same when you flip the entire quantity. Only the exponent outside would change. But I like to get rid of the parentheses first. So I know that's going to be a to the 3 times negative 2 on top and b to the negative 5 times negative 2 on bottom. That's a positive. So that a to the negative 6 isn't simplified. To make it a positive exponent, it's currently on top. It's got to move down, and it will become a to the positive 6. Now you might think, oh, there's nothing left in the numerator, so it's 0. No, it's a 1. It's kind of like you just divided by a to the negative 6. A divided by a to the negative 6 divided by itself is 1. So that ends up being equal to 1 over a to the 6th, b to the 10th.